Hello there, 8th grade. Welcome to a combo lesson for 911 and 912. This one's going to be a little bit vocab heavy, but should have some pretty easy properties for you to use going into high school on these. I am taking the time to focus on these ones because these two topics for 911 and 912, along with the other one this week, are three things that I always saw freshmen really struggle with. And so I want you to take the time to try and understand these as best you can. It is going to be vocab heavy, so feel free to pause it, backtrack, look at the screen, pause it and read the definition if I'm going too fast on these. But I'd really rather this be a quick lesson that is just like a fast review and fast way to cover all of these things. So let's get started. This section, 911 and 912, are all talking about angles. Now, angles in this case are on parallel lines when they're being described here. And in the second half of this, which is 912, is going to be talking about angles in triangles. And there's a few properties that come up and they show up a lot, but there's really only two things that happen in this setup. And I always want you to be thinking about this. Keep this like phrase in the back of your head. When you're dealing with parallel lines or triangles, there's really just two things that happen. Either angles are going to be equal, and in angles and with measurements, they start to use the phrase congruent, but I'm not going to dive into those too much, the difference between those. Either angles are equal or angles add to 180 degrees. And if you're not sure how many degrees is in something or what that means, let's look really closely at just some basic background knowledge. So a degree is how steep or how wide a particular angle is. You may have seen the phrase 90 degrees to represent a right angle. So a corner is 90 degrees as far as that. It is a right angle is what it's called. This little symbol in the bottom is one you'll see often, is what represents a right angle. Now, if you put two right angles back to back, you've got two right angles next to one another. All together, this was 90, this was 90 degrees. That means that this section that goes from one side of the line to the other is 180 degrees. Okay, it is a portion of a circle. It's one of these things that, here's a circle, here's 90 degrees. If you go half of the circle, that is a full 180 degrees. And you may have heard the phrase 180 degree turn. It is something that is flipping 180 degrees. And that also means that if you put four right angles together, you go 1, 2, 3, 4, you have traveled an entire circle, which is 360 degrees, because 90 times 4 is 360. So that's just some sort of like starter knowledge on angles. You can also have some things like an angle that is smaller than 90 degrees is called acute, because it's a cute little angle. And then an angle that is larger than 90 degrees is called obtuse. I don't have anything fun for that one. It's just a fat angle that's obtuse. You've got acute, obtuse, right if it is equal to 90. There is another one that is sometimes used. It is called a straight angle. But mostly we just call those a line, and those are 180 degrees. So it's just a lot of different words, notations for these things, and I just wanted to have that background knowledge established before we go on. You've got those four types of angles, you've got a bunch of these things, and now let's go back to our main thing. In this process, angles are usually equal or they add up to 180 degrees. And I'll show you what I mean by that. So in this case, there's going to introduce some new notation. This set of arrowheads drawn on lines, like if you have a line with arrows at the end, that means that the lines go on forever. And if you have these little tick marks on the line, these little arrowheads on the line, that indicates that the lines are going to be parallel. They go forever in both directions and never meet. There's a joke about the saddest love story in math is parallel lines, because they're so similar, but they will never actually meet. Perpendicular is right angles because they match up in like a T, or they intersect and they make 90-degree angles. And so what happens is when you have parallel lines in a problem, you can have, let's actually do this with a ruler. Let's just make these pretty exact. So if you have two lines that are parallel and they are cut by a third line, which is called a transversal. Now, I'm actually interested in using this because I used an exact measurement, so I actually know, based off the drawing, that this exact value right here is a 30-degree angle. It is exactly 30 degrees right here. And again, that notation is that arrowheads drawn on lines like this indicate that they're parallel. And then if you put an arrow on the end of it, it means they go forever and don't meet. And they go forever like that. They could just continue forever and ever. Now, the reason I mark that 30-degree mark is you might notice that 30 degrees and that particular angle is not the only angle in this shape. In fact, there's usually 8 angles that you're going to be dealing with here. You've got the 30-degree angle right here, and then you've got some other angles. Now, this angle looks to be mighty similar in size to that one, and indeed, it is also 30 degrees because it was drawn at the same angle based off of these parallel lines. And then there's some interesting things that happen here. This angle back here is also 30 degrees. Just because one is 30 degrees above the line and the other one is 30 degrees below the line does not change anything. And conversely, this one is 30 degrees. And now that's a whole lot of angles and degrees written there, and yet there's still more that come out of this. If I tuned out your vision, and let me see if I can do this with a, can I do a white highlighter maybe? Nope, that does not do anything of the sort. So what I'm going to do is I'm just going to cover up or zoom away from a bunch of this. So let's just look at this section of line right there, where all I have is a line and an angle off of it. If you think back to the thing that I was just talking about, what do you know about the degrees of a line? Well, it's called a straight angle, which means this is 180 degrees. Interesting enough. Well, if I had a line cutting out a section of it like this up here, this little section is what I'm looking at, and I knew that this accounted for 30 degrees, and then I asked you, okay, what is the remaining part of this? What is the rest of this angle? The answer is 180 minus 30 to give you 150 degrees, which when you think about it makes sense. If I had a line which was 180 degrees and I cut 30 degrees out of it, what's left is 150. And the thing is that you start getting into some really interesting things here where this angle is 150 because that was the one I was looking at. But I could just as easily have looked at this problem where I only looked at the 30 degrees is here, which would make this 150 degrees, which would make this 150 degrees, and it would make this 150 degrees. Regardless of which section I look at, it makes that exact amount. Now, this particular ruler can't actually do that, unfortunately. It'd be really cool if there was a protractor option on here. Anyway, maybe I'll write Microsoft, tell them to do it. So now you've got a set of parallel lines and a whole bunch of angles that are going to be equal or congruent to one another. I'm using the word congruent because it's technically the right word to use, but what I want to do is look at it when you have a generic picture. Unfortunately, the book's picture here gets a little bit blurry. Okay, the book's picture gets a little bit blurry. So what happens is you can look at a picture like this where you have some different values and start figuring things out. Now, remember back to that trick that I was mentioning, is that angles in this case are usually either equal or they make 180. It's one of the two things. So if I looked at this and said, okay, well, I've got a 123-degree angle right here. Are there any other angles in this problem that have a similar size or shape to them? And the answer is, well, yes. A looks to be exactly the same, right? It's positioned in the same spot. It's the same shape. It's clearly not an acute angle, so this angle also has to be 123 degrees. These two angles have a name. When you're looking at an angle that is in the same spot on a shape, like that, it is what is called a corresponding angle. And there is a bit of definition here. They are on the same side of the line, meaning in this example, angles 1 and 2 are corresponding because they are both on the top left side, and angles 3 and 4 are both corresponding because they are on the bottom right side. So keep that in mind. This is another definition that you can use. So 1 and 2 are corresponding. 3 and 4 are also corresponding. And if I looked back to my example here, a pair of corresponding angles could be the 150 and the 150 right there and right there. Those are corresponding. Also 30 and 30 right here are corresponding. This 30 is corresponding to that one. And this 150 is corresponding to that one. So you notice which ones match up are based off of where they are located, either top right, top left, bottom right, or so on or so forth. So that being said, this angle B over here is also 123. It's the same angle, it's just rotated up that way, it's the same shape. And this is 123. Now, some people have called these what are called zigzag. They call them zigzag angles, which is not accurate. But the reason they do is because it looks like it's making a some letter there. I don't know. I don't know why they call it a zigzag angle. Who knows? There's a proper name for these. This is, in this case, alternate. Okay, they're alternate angles because this one is on the left and this one is on the right. Interior, alternate interior angles, because they are in between the parallel lines, which is why this is the interior part. So the proper name for these angles are alternate interior angles, which are listed in this problem, or in this example in your book. So in this example, you've got, for example, X and Y are alternate interior, and 1 and 2 are alternate interior. And the rule is that alternate interior angles are equal or congruent. I would rather use the word congruent, but they mean the same thing in this case. So you will start seeing problems that have all of these sorts of angles on them, like 1, 2, 3, 4, 5, 6, 7, 8. And if you are asked to list different things, for example, I want to list a pair of alternate interior angles, you might list 6 and 5 because they are on opposite sides of that zigzag. Okay, let me put this image over here and start doing that. So as you start doing this, you're going to start listing out some angles. So let's list out any corresponding angles here, and not in a horrendously large pink highlighter. So corresponding angles. Corresponding angles. That was terrible. Okay. So angle 7 corresponds to angle 5. Angle 3 corresponds to angle 2. I'm just going to keep all the same ones the same. So 7 corresponds to 5. Angle 6 corresponds to angle 1, because they're on the same side there. Angle 3 corresponds to angle 2. And then angle 4 corresponds to angle 8. Those are corresponding angles. And you can get some other angles out of this. You could look at alternate interior angles, which can be abbreviated sometimes as alternate interior angles when your teacher is being lazy. So in this case, you could look for zigzag angles for, that. So this one, I'm highlighting angles 3 and 4. And then I can also look at this in terms of 6 and 5 are also alternate interior angles. And there is one more. So these are both sets of congruent angles. These are equal angles. Those are equal angles. They're also the same. There is another type of angles that are being talked about here. So let's take, for example, let's make this a new color. So if I asked you to give me a name for angle 6 and angle 4, you notice first that they are on the same side. In this case, they're both on the right side. And they are in between the parallel lines, so those are interior. Now, those two angles are clearly not the same size. 6 is obtuse, 4 is acute. They're not the same size. So same side interior angles, so angle 6 and angle 4 match that description, and angle 5 and angle 3 match that description. Now, think back to the thing I said at the very beginning of this process. Angles in this case will usually either equal each other, like they do in the corresponding and alternate interior angles. And the other thing that happens is the same side interior angles could equal 180 degrees. And indeed they do, because any time that you match up two of those, you make a line. Okay, and that is the majority of this parallel line transversal stuff. The reason I'm adding in a whole second section to this in the 912 is specifically because the unknown angles in triangles is very simple. A triangle has 180 degrees. Okay, a triangle has 180 degrees. And if you want to see a really cool description of this, what I'd like you to do, and this is actually something you could do like in your house, draw any size triangle on a paper and then cut it out. So you've got a triangle that you're holding in front of you, and then what I want you to do is cut little curved sections off of that. So like if you cut a section off here, color it in, cut a section off there, color it in something else, cut a section off there, what you're going to be able to do no matter what your triangle started off looking like is to piece those three pieces together, and it will make a perfect semicircle every single time. So try it. It's really simple, it's very useful, but the idea is if a triangle makes 180 degrees, 41 plus 62 plus x makes 180 degrees, and then you solve it. Now, if you guys have any questions for me, that's the entire homework there. I'm not even going to go into detail on that. The idea is they add up to 180 degrees. And you can do more complicated problems like this, where you've got an unknown, a 2x, and a 30. So x plus 2x plus 30 equals 180, and then you solve it. 3x plus 30 equals 180. Try that. Try that for a few of these. You could even get really ugly, horrendous problems like this, where you're trying to find out missing angles in a triangle, and you throw in all the properties together. I can find this angle right here because that angle, which I'll call, let's see, z, because I don't know it, plus 92 makes 180 degrees because they are on a line. I could then find missing angle x up here because this is 88. 36 plus 88 make plus x equals to 180. And then I get that. Okay. And if you guys need help on the homework, please feel free to stop by my office hours on either Tuesday or Thursday. Have a good one, 8th grade.